And let's bring in the Torus. Torus is spelled T-O-R-U-S. It is not a Taurus like a Ford Taurus. It's Torus. So we have the flywheel. The flywheel is going to bolt to the back of the engine crankshaft. But you'll notice there's a hole through it, which means this surface right here has to seal. And there's a gasket that goes there that I'll show you later. That seals the back of the flywheel to the front, or the front of the flywheel to the back of the crankshaft on the engine. You'll notice there are 30 equally spaced holes all the way around this thing, where we have these little grade 8 fine thread bolts that are going to stick through the Torus housing and screw into the flywheel. And yes, there's a giant gasket that goes all the way around this that I'll show you here in a little bit that bolts all of that together. There's a run out test for this. There's a flatness test. There's an out of round test. Several things that can go wrong with this if you're not careful. You don't just throw this thing around like it can't be damaged. All right, so I also want you to see that there is a drain plug right here. This drain plug is used during a transmission service. And back then, the transmission service was every 15,000 miles. There's a special fluid. I can't believe I actually found it. Somebody on eBay was selling this. This is an unopened can of GM transmission fluid number 1 for the Oldsmobile Hydra-Matic drive. This is incredible. Now in the manual for the maintenance manual for this transmission, it says if you can't find the correct transmission fluid, then you can temporarily use 20 weight engine oil as a substitute if you need to. The transmission does have a regular dipstick in it. The top of the dipstick is also the vent for the transmission. So a unique fluid, the very first automatic transmission fluid right here. That's incredible. All right. Now, inside of the Torus, we have what is referred to as the driven Torus member. So this is the equivalent of today's turbine in the torque converter of your vehicle that you're driving today if you have an automatic transmission. This driven member or turbine has a little spring-loaded valve in it right there, that as the fluid pressure gets too high, either from just high pressure or heat, that valve will open up and allow fluid to go into right up the center of that transmission shaft and through some of the other shafts for lubrication. So to lubricate the planetary gear sets and clutch packs and bushings and so on. So this is the equivalent of the turbine. So we will set it off to the side. Also down in here we have what's called the driving Torus member. This would be the equivalent of the converter pump. Now this would normally be welded or bolted right to the outer housing of today's torque converters and would spin at engine speed. But this one does not spin at engine speed. Well, it can, but it doesn't always. Notice it has a set of splines here also. You'll notice we've got the impeller fins here. There's unequal spacing there on a lot of those. I read that that's to reduce the restriction of fluid flow in the Torus itself. Then we have the Torus cover, and I want you to see that it also has splines. It has damping springs to dampen the normal engine pulsations from a 4-stroke engine, just like a clutch would do. And remember, they were trying to replace a clutch pressure plate assembly with a fluid coupling. So this is built in. You don't see this in today's automatic transmissions very often. The number of springs typically is related to how many cylinders in the engine. All right, on the back side of this, we have a sealing surface on the inside and on the outside of this little hub right here, and there's a run-out test for the hub. Okay, let's put the Torus on the gear stack up over here and see how the power flow works through this automatic transmission. Okay, the Torus cover with its internal splines here is going to spline to this housing right here, these teeth right here. Now, since it's going to block our view of these other two shafts, I'm not going to put that on here. But this is bolted to the engine. So this spins engine speed always. That means that this piece right here always spins at engine speed. Notice it has a little keyway right here that drives the fluid pump, one of the two fluid pumps in this transmission. It has an engine speed driven pump in the front, and it has a tail shaft speed driven pump in the rear. And you might wonder, well, why does it have two fluid pumps? It was so that you could actually push start this a vehicle with this transmission in it. If you push start the vehicle and got it going up to around 25 miles an hour, the rear pump would develop enough pressure to apply the right components to send power to the engine crankshaft to crank it over and hopefully start the engine. Today's transmissions, you don't push start. Most of them you shouldn't even push or tow because you'll damage them, although some can be. All right, so I'm going to get this Torus cover out of the way, and I'm going to bring in the driving Torus member. Fine splines. It's going to spline right here. So I'm going to slide that right up here. Here we go. And of course, there's a snap ring to hold that in place. Whoops. Okay. All right. Then there's another snap ring groove right here to keep the driven Torus member from moving forward too far. So let's get that snap ring in place. Here we go. All right, now let's install the driven Torus member. Now, if you look at these, they look identical. The theory here is that with the fluid inside of this housing over here, encapsulating all of these devices, as the engine spins the driven or the driving Torus, it'll centrifugally force fluid out to the edges, hit this driven Torus member, and cause it to want to rotate also, but with some losses. That's the slipping of a fluid coupling. So if we slide this up on here, there we go. Notice there's threads on the end of this main shaft here, and there's actually a nut that holds that in place. Here we go. Okay. So with all the snap rings in place, we can take a look at the side view of this Hydra-Matic transmission. So notice there's a gap between the driving Torus and the driven Torus. Although these parts look very similar to the insides of a traditional torque converter of today, they operate quite differently in this first mass-produced automatic transmission. So, what's unique about it is that instead of the driving Torus right here always being connected to the engine and rotating at engine speed like today's torque converters do, it is connected to the engine through the front planetary gear set. So the front planetary gear set can either be in gear reduction, which would give us a 1.45 to 1 ratio versus the engine of reduction. So it would take 1.45 turns of the engine to get 1 turn of the driving Torus. Or if we apply the clutch pack in here and connect the cover to the sun gear, or I'm sorry, the sun gear to the planet carrier, then it's a 1-to-1 gear ratio. So that's what I couldn't understand for the longest time, because I'm used to this piece always being turned at engine RPM. Well, it's not. In first gear, this is rotated at the 1.45 to 1 gear reduction. And from what I read, that was to make the fluid coupling less efficient. And the reason for that is if you're sitting there at idle in gear, engine running in gear with idle, it would be less likely to want to make the vehicle move forward on its own without you stepping on the throttle. So they made it less efficient on purpose with this early fluid coupling. So in first gear, it just alternates first through fourth. It's released in first, applied in second, released in third, applied in fourth. So gear reduction, direct drive, gear reduction, direct drive, 1, 2, 3, 4, through the driven or the drive Torus member. I've never seen that before. I never even thought about it. Didn't even know it was possible. All right, the driven Torus member, this back piece here, it turns the main shaft that goes clear back to our rear planetary gear set back here. And it is either going to have a 2.63 to 1 gear reduction when the band is applied and stops this ring gear from rotating, or it'll have a 1-to-1 ratio to the output shaft when the band is released and the clutch pack is applied, and it will turn 1-to-1 right through the back of the transmission. So basically, this is, if you think back to those patents we initially talked about in the history, this is a 2-speed transmission coupled to a 2-speed transmission. The front 2-speed is connected to the driving Torus. The rear 2-speed is connected to the driven Torus. And this is called a split torque design. And the combinations of these give us 4 forward gears. And then clear back here in the back, we have a reverse possibility. Now on the early models, 1940 through 1949, they had what is called a reverse anchor. This piece right here, reverse anchor. For those of you who are familiar with automatic transmissions, that looks like a parking pawl, but it's not a parking pawl. This did not have a park position. This had neutral, drive, low, and reverse. But to get reverse on this transmission, you'll notice there's a bunch of lugs right back here. This reverse anchor would have to come and lock itself in to one of these lugs. So if it's not locked in place, it'll grind like that. When it locks in place, it's physically, without hydraulics, stops the reverse gear set internal gear, ring gear, from rotating. In reverse, we don't use the rear planetary gear set at all. We only use the front planetary gear set. And notice that if I turn the Torus one direction, the output shaft turns in the opposite direction with a gear ratio of 4.31 to 1, which is a reduction combination of 1.45 in the front and 297 in the reverse for an overall reverse gear ratio of 4.31 to 1. All right, so let's quickly go through first through fourth gears. All right, let's go through the power flow first through fourth gear on this transmission. So in first gear, the front band is on, the front clutch is off, the rear band is on, the rear clutch is off. So both clutch housings are held still with the bands, and we'll turn with the engine, the Torus cover, which gives us a 145 to 1 gear reduction through the front planetary gear set, and through the driven Torus member, we will turn the sun gear of the rear planetary gear set, which gives us a 263 to 1 gear reduction. That is a compound gear reduction all the way through of 3.82 to 1. I can't demonstrate that for you because I would need to turn 3 pieces at once, and I only have 2 hands. Now, second gear, we turn off the front band, so we release that, and we turn on the front clutch. So now instead of stopping the front band or front housing from rotating, we're going to force it to rotate. That'll give us a 1-to-1 gear reduction through the front planetary gear set. The rear planetary gear set, the band is still applied and the clutch is still released. So now we have a 1-to-1 gear ratio in the front. We still have the same 263 to 1 gear ratio in the rear. 1 times 263 gives us a 263 to 1 overall second gear gear reduction. In third gear, we apply the front band, release the front clutch. That gives us a 145 to 1 gear reduction in the front. In the rear planetary gear set, we release the band and apply the clutch, which turns the ring gear, gives us a 1-to-1 gear ratio through the rear. So we have 145 in the front times 1-to-1 in the rear, gives us a compound overall gear ratio in third gear of 1.45 to 1. Fourth gear is totally unique in this transmission. We have the front band released and the front clutch applied. So we have a 1-to-1 gear ratio in the front. We also have the rear band released and the rear clutch applied, which gives us a 1-to-1 gear ratio in the rear. Now that gives us 1-to-1 in the front, 1-to-1 in the rear, which compound-wise gives us 1-to-1 or direct drive all the way through input to output. But it's even more than that because the engine is turning the planet or the front planet ring gear at engine speed, and the front clutch pack is applied, which locks this up. That means with this front clutch pack applied, the engine is directly bypassing the Torus driving and driven members, and we have a 1-to-1 connection from the engine to the front planetary gear set. So not only is fourth gear direct drive through the two planetary gear sets back here, but it's direct drive from the engine to the front planetary gear set. So this is like a manual transmission in fourth gear. It's total direct drive all the way through, front of the Torus to output shaft, total direct drive, which is pretty efficient. Under those situations, there's no heat buildup here because there's no slip. And these transmissions do not have transmission coolers. The ones that went in the M5 tanks and other military applications had a deeper oil pan that had a heat exchanger for engine coolant to go through and have the heat transfer out of the transmission fluid into the coolant. But these don't have cooler lines. There's no external cooler. And I'm pretty sure that's because of the direct drive connection in fourth gear. Now, there is a patent by one of the 5 team members that helped design the overall Hydra-Matic transmission back in 1940, where they added little fins to the Torus cover back here. They were just little bolt-on fins. So all those 30 bolts, not every bolt, but every so many bolts had a little plate bolted to it that would dissipate heat. And then the lower cover of the bell housing had openings in it to be a heat exchanger with the air for the ones that overheated. All right, let's talk about reverse on this transmission. This transmission does not have a park position as we have today that engages a parking pawl into a parking gear. But on this transmission, it has a reverse anchor, as we talked about, that stops the reverse planetary ring gear from rotating. But with the engine off, when you shut the engine off, the rear planetary gear set band is spring-loaded to the applied position. When you stop this rear planet ring gear from rotating with the band, that stops the reverse planet carrier from rotating, which also stops the ring gear from rotating. And double that up with the reverse anchor going in there, what people found is that if you put the transmission in reverse and shut the engine off, that the vehicle would not roll because the gear set is locked up two ways, the band and the reverse anchor. That stops the output shaft from rotating, and that's the equivalent of today's park. We have a mechanical device that applies park. Some of the brand new transmissions have a solenoid that still engages a mechanical device for park, but it's a mechanically applied device. Now, technically, to park this thing, you were to put it in neutral and apply the emergency brake that they had back then. But this morphed its way into or evolved into the park position of vehicles of today. There's one thing I forgot to show you on this stack up of the parts here. You'll notice the end of the reverse ring gear housing here has a tapered cone on it, and there's a special hydraulic cone clutch that is going to push up inside of here with a tapered cone, and it pushes into this aluminum cone that wraps around that. It acts like a manual transmission synchronizer like that Earl Thompson developed, and will slow down the ring gear when you go to reverse so that the reverse anchor can apply. The internal part of that reverse cone clutch is right here in the tail shaft housing. So this aluminum cone clutch pushes into the back of this housing, which squishes it in to this, which is in the back of the transmission housing. A kind of a strange but unique design for getting reverse a little more quickly, I believe. It has an anchor point at the bottom here that keeps it from rotating in the case. You can apply hydraulic pressure, air pressure to this port right here and see the piston move forward and backwards. Okay, so I've got some compressed air here. I'm going to put a little air to this piston and you'll see it move forward. There's little return springs here that push it back. So that would stop that reverse planetary gear set ring gear from rotating so the anchor pin can apply. While we're here looking at this output housing, there's a speedometer cable drive gear in this housing right here, and that is driven right here on the back of the transmission. It has a gear that as it rotates will rotate the speedometer cable. So a little gear here, mechanically driven off of the output shaft for your speedometer. We've got another gear I already showed you for the rear oil pump. Okay, well, that is the power flow and the components of the main housing of this Hydra-Matic transmission, 1940 through actually 1955 in some models. Cadillac quit using it in 1953 after a massive fire that destroyed the plant where these were made. It took them 9 months to relocate and start producing them again. The next thing I want to look at are the hydraulic components that do the applying and releasing of the clutches, the bands, the fluid flow for lubrication and feeding the Torus itself, and for pressure regulation and the governor and the throttle pressure and all that.